Welcome back to the 3ds Max Basic Modeling online class. I'm your instructor, Miss Jan Yung.
Instructor, we've already finished the mid-poly model in the previous lesson. In this class, we'll be adding supporting edges to it. So, what are supporting edges?
Let's first understand why we need to add them. As we covered at the beginning of this course, a high poly model refers to a high precision model. Such models contain a high density of polygons, designed to reproduce the structures and details of the original concept art as closely as possible. As shown in the image, a high-density polygon mesh can be achieved in 3ds Max using the Turbo Smooth modifier. This makes the model appear smoother and more refined. However, before applying Turbo Smooth, we need to add supporting edges. Here, I have a simple square. If we apply Turbo Smooth directly, it will turn into a circle. To maintain the square's original shape, while increasing its polygon count for a smoother appearance, we need to add supporting edges along all structural edges. After that, apply Turbo Smooth again. The model will retain its shape, while achieving the refined look of a high poly model.
Instructor, what should we pay attention to when adding supporting edges?
First, every structural edge needs supporting edges. Second, the distance between supporting edges affects the smoothing of the model's edges. The tighter and denser the edges, the sharper the structure. The looser and fewer the edges, the softer the structure. Alright, now let's open 3ds Max and follow along. Here in Max, this is the mid-poly model we completed in the last class. Let's first align the overall shape and size. Select the second part. On the coordinate axis controls, enable Effect Pivot Only. Click Center to Object, then set the Z-axis to 0. Disable Effect Pivot Only, then zero out the Y-axis. Uniformly scale parts 2 and 3, so that they match the general size of part 1. Move them slightly apart. After adjusting the size, we need to reset X-form on the models. Select all the parts. On the right, open the Utilities panel, the 6th tab, and find Reset X-form. Click Reset selected, then right-click and convert them to editable poly again. Now they're ready. Next, place the reference with supporting edges at the top of the viewport. Let's follow the reference to add supporting edges. Start by adding supporting edges to part 1. At the top of the viewport, open the ribbon, Graphite Modeling Tools. You can see it's currently active. With the ribbon active, expand it. Click the white triangle icon. To expand the menu, find Swift Loop and enable it. This lets us quickly add supporting edges to the model. Now follow my cursor and add supporting edges at the same positions. Add a supporting edge there. Once done, right-click to exit Swift Loop. After adding edges, the model may look dense and messy. We'll need to optimize the edge flow. Press F to switch to the front view. Select the vertices at the corner. Then select the corresponding vertices diagonally. Press Ctrl plus Shift plus E to connect them. Rotate the viewport and check if the back side is also connected. After confirming, go back to the front view. Double-click to loop select these two edges. Press Ctrl plus Backspace to delete both the edges and their vertices. After deleting, you can see the inner corner now forms a trapezoid. This gives us the clean quad structure we want. Do the same here. Double-click to loop, select the edges. Press Ctrl plus Backspace to delete the edges and vertices. Have a look, everyone. Now our edge loops look much cleaner. We've ensured each corner has 3 supporting edge loops to hold its shape, and the overall topology looks even and organized. The top and right sides still need supporting edges. Use Swift Loop again to add them. Exit sub-object mode. Press P to switch to the perspective view. Now, apply a Turbo Smooth modifier. Check if the result matches what we want. You can see each corner is supported by 3 edge loops. The shape remains cubic, while the surface appears smooth yet structured. That's exactly the result we're looking for. Now that this is done, let's move on to the second part. First, adjust the 2 upper edge loops. Move them slightly along the y-axis to make the faces more evenly distributed. Take a look at the second part. Its left and right sides are symmetrical. So, switch to the polygon sub-object level. Select one half of the polygons and press Delete to remove them. Then mirror the other half as an instance. After mirroring, start adding supporting edges. Double-click edges to loop select them. Hold Ctrl to add to the selection. Select all structural transition edges of Part 2. Rotate the view and check that every structural transition edge is selected. With the selection active, right-click and open the chamfer dialog. Increase the chamfer amount. Expand the first drop-down. This is the 2023 version. You'll see 5 chamfer modes available. Let's try them out. For example, quad chamfer. With quad chamfer enabled, the corner transitions look more even. We can also test the other modes. After testing, radial chamfer is most suitable for this supporting edge step. In a moment, one extra step will convert these into quads. So choose radial chamfer and confirm with the check mark. Now, notice the selected vertex corresponds to an n-gon. Simply connect it to the opposite corner across the diagonal, splitting the n-gon into 2 quads. Do the same at the bottom, connect diagonally, and split it into 2 quads. Apply a Turbo Smooth modifier. You can see the result is very smooth. That's because we've kept almost every face a quad. Orbit to inspect the surface. Only the mirrored seam isn't smoothing correctly. We'll use a different approach to mirror the other half. First, delete the mirrored half. Select the remaining half and add a symmetry modifier. Set the mirror axis to X. Ensure Z is not selected. If the other side doesn't appear, enable flip. After symmetry, add a Turbo Smooth modifier again. Now, along the symmetry axis, the smoothing looks correct. The supporting edge pass we just did for Part 2 was in the 2023 version. Its bevel behavior differs from older versions. So I'll demonstrate the supporting edge pass for Part 2 again in the 2018 version. First, mirror this half with the symmetry modifier, then collapse the stack back to editable poly. Click the small icon under my cursor. Toggle Show End Result on. Now, you can see the symmetry result while editing at the editable poly level. Switch to the edge sub-object level. Hold Ctrl to add to the selection and double-click to loop edges. Select all structural transition edges. Orbit to check for any missed areas. Add them if needed. Once confirmed that all the target edges are selected, right-click to open the chamfer dialog. Set segments to 2. You can see the edge flow is noticeably different from 2023. Where many edges converge, the chamfered lines can become messy. Open the chamfer mitering mode. There are only 2 modes here. Switch to quad chamfer. This produces more supporting edges. Set segments back to 1. This is the quad chamfer result in the 2018 version. Compare it with the reference topology. Right-click and use Cut to reroute this edge. This one should connect to the middle. Delete any unnecessary edges. Our goal is to form a chan-shaped quad grid here. Move the needed vertices into place. Do the same on the left. Use Cut to reconnect the edges. You can complete the loop around once. Keep faces as quads wherever possible. Press Ctrl plus backspace to remove extra edges and their vertices. Take a look. The multi-edge junction is now a neat chan-shaped quad grid. Switch to the vertex sub-object level. Nudge vertices slightly to even out the topology. Use Cut at the bottom as well to reroute the edges. Same method as above. Complete the loop. Connect the center vertices. Then space them more evenly. Double-click the extra loops, then press Ctrl plus backspace to delete. Good, that works. Apply a Turbo Smooth modifier. Now compare 2018 and 2023. The overall Turbo Smooth result is essentially the same. Only the underlying topology or edge flow differs slightly. Both 2018 and 2023 workflows are valid for supporting edges on Part 2. Our aim is even topology where there's no structure. And in areas with structure, especially where many edges meet. To route the edges carefully, keeping faces as quads. Now switch back to the 2023 version. We'll add supporting edges to Part 3. Go to the edge sub-object level. Double-click to loop select the following edges. Press Ctrl plus backspace to delete the selected loop. Deleting it will make it easier to loop the edges. Take a look here. By double-clicking, I can loop select the entire ring of petal edges. All these cylindrical edge loops can be selected by double-clicking. Select all the structural transition edges. Then, open the chamfer dialog. Increase the chamfer amount slightly. As you can see, Part 3 has the most complex structure among the 3 components, but it's also the quickest to process for supporting edges. That's because every curved or transition area can be loop selected directly. Once you've selected the loops, apply a chamfer, and the supporting edges are done. Apply a Turbo Smooth modifier to preview. This is exactly the effect we want. Now, all 3 parts have finished the supporting edge process, and their topology has been optimized. Yibao, from what we just practiced, what methods did we use for adding supporting edges?
Teacher, we used Swift Loop, chamfer, and cut. I noticed that the workflow differs depending on the model.
Exactly. As long as we understand that the goal of adding supporting edges is to preserve the structure of the high poly model, we can flexibly choose the most suitable method in each situation. I hope that in your future high poly projects, you'll be able to apply these techniques with confidence and flexibility. Alright, this concludes our project.